Okay, so let's start working through our Chapter 2 test review. So question number 1 is asking if the relation is a function. If we go back to our notes, we know that in order for it to be a function, you can have no repeats in the domain, and if it's a graph, it has to pass a vertical line test. Meaning that if I draw a vertical line anywhere on the graph, it should only cross it one time. So let's look at our ordered pairs. Focusing only on X, I have a 4, a 5, a 6, a 7, and an 8. They're all different, so this would be yes. For our graph, I could draw a vertical line. It only crosses it one time, and it doesn't matter where I draw that vertical line. It's always only going to cross it once, so that is also a yes. And for graph C, which is a square root function, when I draw my line, it only crosses it once. I can move it, it still will only cross it once. So on our review, all 3 are functions. Okay, so the domain. All right, so remember there are 2 red lights. You cannot divide by X. Sorry, you cannot divide by 0. So if there is an X in the denominator, we need to remove that from the domain. So in order to factor down, I'm only focusing on my denominator. So this would factor down to, you would need 2 numbers that multiply to give you negative 24 and add to a negative 2, which would be negative 6 and positive 4. So my factors would be X minus 6 and X plus 4. When I set both of those equal to 0, I get that my first value, that X cannot be, is 6. And the second value that X cannot be is negative 4. So on the number line, this is saying I can use anything from negative infinity to positive infinity except negative 4 and positive 6. So these would have an open circle. So when I write my interval, there's 3 intervals that I need to write. So my domain for question A is negative infinity to negative 4, and then my middle union for negative 4 to 6, union, and 6 to infinity. Notice that I don't have any hard brackets. If you use a hard bracket, that means that we can use the values that I'm trying to take out. And we can't. This would be my domain. Now for a square root, you can take the square root of 0. If you use your calculator and you type in the square root of 0, you will not get an error. The error comes when you try to use numbers that are less than 0. So that means that when I write my inequality, it has to be greater than or equal to 0. So I'm going to do a little bit of algebra, adding the 3 and dividing by 2. This tells me that the values that I can use for this function and not get an error in my calculator is any number greater than or equal to 3/2. So bracket on the 3/2 because we can use that all the way to infinity. All right, when we're looking at a graph, let me zoom on in here. We're going left to right, so I have to figure out what is this point on my graph. So if I hop over, that would be -1, -2, -3, -4. And my values are getting bigger. So for this function, it would be -4 to infinity. That's my domain. Now I know that it didn't ask me for the range, but I'm gonna just talk about it really quickly. Even though this question is not asking us to, the teacher in me just has to talk about it. When we talk about range, we're going from the bottom up. So what I'm saying is, I'm reading it going upward. So if I'm reading it from the bottom, I see that my graph is pointing down. It has an arrow going down. That tells me that my lowest y value is -infinity. And then it stops when we get here. So what is that value? 1, 2, 3, 4. So it would be to +4 with a bracket. And again, it did not ask for the domain for C, but it didn't ask for the range for C. I just had to talk about it because I just couldn't help myself. All right, so now let's look at question number 3. We have our function. We have to do some substitutions. Now we have a quadratic. So I have to put this in both places. And then we're just going to follow the order of operations. So f of x says 2x squared minus 3x plus 2. The -2x will go inside. And then we do our order of operations. The first thing I'm going to do is square -2x, which means that I'm taking -2x times -2x, which is 4x squared. And now I'm ready to multiply, which this gives me 8x squared. And negative times a negative gives me a +6x and a +2. Now, for our next one, it's a very common mistake that we do not multiply out that 3x minus 2 correctly. So we're going to start off again. So my function says 2x squared minus 3x plus 2. And this time, I'm putting a 3x minus 2 on the inside. So this is the biggest mistake right here. Right here. This is where deadly mistakes are being made that we cannot do. We need to FOIL, distribute, whichever method you prefer. We need to properly multiply out that 3x minus 2 times 3x minus 2. And there's a lot of different ways. Some of you don't make a box, and that is fine. But what you cannot do is that and say that it's 9x squared plus 4, because that's wrong. That is wrong. We cannot do that. We need to multiply it out fully. So we have 9x squared minus 6x minus 6x and a plus 4. Now these are not opposite. These two squares, so they don't cancel. They're going to stay. We're going to add them together and it becomes a -12. So I have a 2. Make a little bit bigger of a parentheses this time. And now inside of the parentheses, I'm going to drop in what I got, which is a 9x squared, a minus 12x, and a plus 4. And then again, I still have my 3x minus 2 here. And now we're ready to distribute. When we distribute, multiplying everything in this parentheses by a 2, by positive 2, that's going to give me 18x squared minus 24x plus 8. And then I'm going to distribute a negative 3. So negative 3 times positive 3 is a is a negative 9x. But a negative times a negative will give me a positive 6 and then plus 2. Then my last step is just to combine our like terms. So we only have one quadratic term. We do have 2 linear terms. So negative 24 minus 9 is negative 33x. And I also have 3 constants. So I have 8 plus 6 plus 2, which would give me a 16. And that is my answer. So question number 4 is a little tricky because there's so many different ways that you can approach this question. There's not just one answer. I'm going to show you a sample, but I want to make sure you understand that you don't have to make it exactly the way I am going to draw it. The main thing I'm looking for, do you have the correct discontinuity at the right location? They all need to kind of connect in some kind of way. I'm saying it has to flow from left to right, and it has to pass the function test. So the first thing I like to do is start by identifying where am I putting my discontinuity. So my first one is going to be at negative 4. So that's going to be, let me see, 1, 2, 3, 4. It is really hard for me to see. I feel like the lines are moving on me, okay? And then I have another one at 0. That has to go about here. And then I have another one at 3, which is right here. All right, so we're going to start off with our infinite at negative 4. So that means along this green wall, my graph needs to either go up the wall towards positive or roll down the wall. It doesn't matter. Again, so what I'm going to do, and this is actually going to be like a piece of a rational, which we'll talk about more in chapter 4. I'm just going to have it going up on this side, and I'm going to have it do the same thing on the right. It's going to come out. But now when I get to that red wall, it says I need to jump. So what I'm going to choose to do is I'm going to stop at the red wall. So that means I have to stop at the red wall. I'm going to put open or close. I'm going to go with closed. And I just need to figure out where this graph is going to jump to. Is it going to jump up or down? Let's see. I think I'm going to have mine jump up. So it's jumping up to right here. Now, remember, both of these cannot be closed. One of these has to be open. They can both be open, but they cannot both be closed. So now I have my point, and now I'm back traveling. When I get to that blue wall, I got to put a pothole or a removable. And then I am just going to have it go straight and make it constant. And that would satisfy all 3 discontinuities. It would be the right discontinuity in the right location, and it would pass the vertical line test. But again, this is a sample. And if you look at the answer key that I posted on Canvas already, I drew something completely different. So these are samples. So let's look at question number 5, even, odd, neither. So we need to substitute a negative x in for every spot where there is a positive x. So I'm gonna go ahead and start this off here. All right, put in my negative x. So I know that when I square this negative, it is gonna go back to a positive. But here, when I multiply these together, oops, wrong thing. When I multiply that negative and the negative, it's going to switch to a plus. So when I compare these two equations, notice that all the signs did not change and they all didn't stay the same. Some stayed, but one of them changed. And because that x changed, this would be considered neither. It has no symmetry. If you graph it using a graphing calculator, it's not symmetrical with the y-axis. It's also not symmetrical with the origin. All right, let's go ahead and look at B. So I have x to the fourth plus 3x squared. Again, I'm putting in my negative x. Now we do know that whenever we take a negative to an even power, like 4 and 2, they stay. Or they don't, sorry. They go back to the original form because the negative squared is positive. So when I take the negative to the power of 4 and I take my negative to the power of 2, they're both going to flip back to positive and give me the exact same function that I started off with. So comparing these two, it's a match, complete match, which tells me that this graph has y-axis symmetry or even, same thing. And then our last one, I have x to the power of 3 minus x, and I put in my negative x. Okay. I'm taking both of these to an odd power, because remember, my invisible exponent here is 1. 3 and 1 are both odd, which tells me that the negative will stay. So it's going to stay, which is going to make this become a negative x cubed. And this is going to flip to a positive x. And when we compare these two functions, they're completely opposite. We only had two terms, and they both flip signs, which tells me that this is an odd function. All right, so let's look at question 6. Determine the rate of change on the interval. So both of these are my x values. This is x1 and this is x2. Your very first step would be to substitute in both of these x values. Now, I would personally, at this point, I would pause the video and try to work it out on your own to see if in the end you get the same answer that I am going to get. So that would be my recommendation. So I'm substituting in my negative 2, and then I'm also going to substitute in a positive 5. And when we do that, so go ahead and pause the video and see what you get, and I'm going to finish it out. Okay, so what you should have gotten was a negative 7 and a positive 105. So that means that my order pairs are negative 2, negative 7, and positive 5, 105. So this is my x1, y1, and this is my x2, y2. And the formula for slope, going back to good old Algebra 1 days, y2 minus y1 over x2 minus x1. So my slope is going to be m equals 105 minus negative 7, and that's going to be over 5 minus negative 2. And we know that when we add, when we subtract something that's negative, it becomes addition, which is going to give me 112 over 7. And out of space here, but if you divide, well, it doesn't divide, sorry. So I'm going to leave it as a fraction. So my rate of change is just going to remain 112 over 7. And that would be my answer. So we're going to do, number 7 is asking us to create a function and then state the domain of that function. And what this is just telling me is to make a fraction and put the f of x on the top and the g of x on the bottom. So my function would be 3x plus 1 over 2x minus 5. Now remember, it is the denominator that controls our domain. So what I'm going to do, because you can't divide by 0, that tells me that 2x minus 5 cannot be 0. So if 2x minus 5 cannot equal 0, I'm going to do a little bit of mental math. I'm adding 5 and dividing by 2. That means that x cannot be 5 halves. So from negative infinity to positive infinity, but not 5 halves. So that means negative infinity to 5 halves, union 5 halves to positive infinity. So we have our domain, and this is our function. So I'm going to end after this and start and do a part 2 later, but let's look at question 8. So we have 3 different functions, and we just have to do different operations using whatever 2 functions they're asking us to. So we have our f, and then we have g, go ahead, I'm trying to highlight everything. Okay, so that's f. And then I have j. Okay, so the first one is telling me to just subtract. Subtract the f, take f minus g. So f minus g would be x squared plus 3x minus g, which is 5x minus 9. Now we're going to distribute because it's subtraction. And when I combine my like terms, I get x squared minus 2x plus 9. Let me highlight that. That would be my final answer right here. That's what I'm looking for. Now, for the, so what I just did there, let me make sure we understand, is I took f of x minus g of x, and I combine like terms. B is the easiest one because just like number 7, we just need to make a fraction. Put the f on top and the g on bottom. And we don't even need to simplify it. We're just going to leave it just like that. So I'm going to make my fraction bar. In the numerator, I have my f of x. In my denominator, I have my g of x. And I'm done. For questions C and D, we have actual numerical values, okay? So what this is saying is to take g of 2 and then add that to j of 2. So if I take g of 2 is 5 times 2 minus 9, which is just 1. And then if I find j of 2 is just 2 squared plus 10. 2 squared is 4, and 4 plus 10 is 14. And then I just simply need to add these 2 numbers together. So my final answer is 15. If it said subtract, I would do 1 minus 14. If it said multiply, I would do 1 times 14. But this says add, so I'm going to add them and get 15. And then lastly, for this first part, I'm going to find, make me a little All right, so I'm going to find j of 3, which would be 3 squared plus 10, which is 19. And then I'm going to find g of 3, which is 5 times 3 minus 9. And that's going to give me 6. And I'm just multiplying those together. And when I take the 19 times the 6, I get 114. All right, so that is the first part of our review. And I will work on part 2.